Today we're going to start our unit on organic chemistry. And this is a different unit from chemistry that we've done before. It's going to require you to be more disciplined and really keep on top of this material. Organic chemistry is the chemistry of carbon compounds, and you might have heard horror stories about how hard organic is and how difficult it is. We're doing a very brief overview, probably the equivalent of maybe the first day of a college organic course. It's totally accessible, but it does still require learning and discipline, which is similar to what you'll see in biology. The carbon compounds are called hydrocarbons because they're made of hydrogen and carbon. And carbon can make 4 bonds that are very strong. The chemical formula is the notation using symbols and numbers to represent the composition of a substance, whereas the structural formula shows the arrangement of the atoms in the molecule. And both of these are useful. We're going to start with learning the alkanes. They are saturated hydrocarbons, meaning that every one of the 4 possible bonds on the carbon is bonded to something different. There is nothing that is double or triple bonded. They follow the formula CnH2n plus 2, meaning you're going to double whatever the number of carbons. The hydrogen is going to be double whatever number the carbons are plus 2 more. These molecules only have single bonds, like I said a minute ago. That means they're saturated. And the suffix on their name is ane. You have to know these prefixes for all of organic chemistry. They're not all that different. Meth, eth, prop, and bute are the 1, 2, 3, and 4, and they're a little bit different. But I think you'll find that pent, hex, hep, oct, non, and dec all are very similar to geometry. So it's really the first 4 that you need to make sure you know, although you'll need to know all of these, so you just want to make sure that you know them. So write the chemical and structural formula for the following. Methane. So methane was our one with 1 carbon, so it's just going to be CH4. My structural formula will be C with 4 H's bonded to it. Propane is 3 carbons, so it's C3 and then H. Remember it was 2N plus 2, so 3 times 2 is 6 plus 2 gives me 8. And if I draw it 1, 2, 3, and then go ahead and saturate it by putting a hydrogen at every spot, 1, 2, 3, 4, 5, 6, 7, 8. And then pentane, which is C5H, and then that'll end up being 12. 2 times 5 is 10 plus 2. 1, 2, 3, 4, 5. And then I'm going to go ahead and saturate it with my hydrogens. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Naming branched alkanes is a little bit different. It requires some other rules. You're going to need to write down this list. You need to find the longest chain of carbons. This is called the parent chain. This may not be a straight chain. You have to look for the longest chain. It could be bent. Number the carbons in the parent chain starting at the end closest to the first branch. This branch is designated with a number and has the suffix YL. If more than one of the same kind of branch is found, use the prefix di, tri. And if more than one kind of branch is found, list them in alphabetical order, disregarding any prefix. I know this seems confusing, but this is the rules for all of organic. And so I know it says for alkanes, but this is going to hold true for all of our naming. So you want to make sure you just get practice. There's going to be a lot of practice in class. Draw the structural formula for the following. 2-methylpentane. So pentane is telling us here that this is our parent chain. So pent is 5, So we have 1, 2, 3, 4, 5, and then it wouldn't matter where I numbered it from. It just makes sense to number it from here. So this would be 1, this would be 2, and a methyl group is 1 carbon. So I'm going to stick my carbon here, although it wouldn't matter if I stuck it down below. And now I'm going to go ahead and give all of my carbons, make them all saturated with their hydrogens. Our next one is 2,2-dimethylhexane. Hexane is our parent chain. Hex is 6. So I'll have 1, 2, 3, 4, 5, 6. 2,2-dimethyl. Here's 1. Here's 2. That means I have 2 of them here, and they each have a methyl group. And now I can go ahead and add in all of my hydrogens. Okay, we're going to assume that there's hydrogens at the end of all of those. I have 2,4-dimethylhexane. In this case, again, I have hexane. 1, 2, 3, 4, 5, 6. It's dimethyl, which means I have 2 methyl groups, but it's at the 2 position. 1, 2. It doesn't matter if I put it top or bottom. And then 1, 2, 3, 4. Doesn't matter if I put it top or bottom. Just to make it different, I'm going to put it on the bottom. And now I'm going to go ahead and fill in all of my hydrogens. And now I have 3-ethyl-2,5-dimethylheptane. So let's start with our parent chain. 1, 2, 3, 4, 5, 6, 7 for heptane. So on 2, I have a methyl group. Let's put 1 here. On 5, 1, 2, 3, 4, 5, I have another methyl group. Wouldn't matter if I put it top or bottom. And then on my third, 1, 2, 3, I have an ethyl group, which is 2 carbons. And then I can go in and add in all of my hydrogens. Isomers, a substance that has the same chemical formula as another substance but differs in structure. So it says draw and name the isomers of pentane. So pentane is C5H12. So I can draw anything that's C5H12 as long as it's different. Well, there's always the main chain, so just regular pentane. And then I can move these carbons around. So an isomer means that I still have 5 carbons, but I can put them any way I want. If I went like this, this would still be pentane. It's still a 5-parent chain. And so that would not count as an isomer because it doesn't have a different name. If I put a carbon here, now I have butane as my main chain, and I have a methyl group at the 2 position. So it's 2-methyl butane. If I did this, and I move that methyl group one place, this and this are still the same thing because this is still a butane, and I always start numbering from the closest branch. So this would become 1 and this would become 2. So these 2, in fact, are exactly the same, and this doesn't count as a new isomer. The trickiest thing about isomers is learning to see when they're different. There's one more isomer of butane, and the only other thing I can do is put all my carbons like this. And This means my main chain is 3, which is propane. And so I end up with 2,2-dimethyl propane. And those are my 3 isomers of pentane. And now we're going to look at some reactions with alkanes. At very low temperatures, alkanes are not very reactive. At high temperatures, alkanes combust, and we've already done combustion reactions with hydrocarbons. So butane combusts in air. Butane is 4 carbons, and so it's C4, and then 2 times 4 plus 2 plus 10. We know combustion is always plus O2, and we know our products, CO2 plus H2O. Remember when we had all these compounds and you didn't know what they were? Well, now you'll know what they are. We'll go in and balance this. Oops, I'm sorry, this is, yeah, that's good. And then we're balanced for our reaction. Our second reaction is a substitution reaction, where one or more hydrogen atoms are replaced by a different atom. This is almost always a halogen, so a Cl2, a Br2, that sort of thing. And so if we look at this, if we have CH4 plus Cl2, we're going to take one of these hydrogens off and give it to Cl, and we're going to put one of these Cl's on. So what we end up with is C, Cl, and then HHH. Again, it wouldn't matter where that Cl went, which side it was. And then one of these H's went to the other Cl to make hydrochloric acid. And then our final reaction is a dehydrogenation reaction. Hydrogen atoms are removed and the product is an unsaturated hydrocarbon. And this will make a little more sense when we start alkenes next. But basically we have CH3CH3, which is our same thing as C2H6. But we can write it that way and we can write it this way. Those are all the same thing. And what we're doing is we're taking away 2 of the hydrogens. And by taking away, let's say, this hydrogen and this hydrogen, we're left with C's needing to double bond. But notice that each C always has 1, 2, 3, 4 bonds, and then that forms H2. And that will end our information on alkanes. I know it's a lot to take in, but it's also the first unit of the chapter. I suggest you go through this and go over this, and it's going to take very careful practice in class to make sure that you master this material.